Forensic engineering is the investigation of materials, products, structures or components that fail or do not operate or function as intended, causing personal injury or damage to property. The consequences of failure are dealt with by the law of product liability. The field also deals with retracing processes and procedures leading to accidents in operation of vehicles or machinery. This subject is applied most commonly in civil law cases, although it may be of use in criminal law cases. Generally, the purpose of a forensic engineering investigation is to locate cause or causes of failure with a view to improve performance or life of a component, or to assist a court in determining the facts of an accident. It can also involve investigation of intellectual property claims, especially patents. Vital to the field of forensic engineering is the process of investigating and collecting data related to the materials, products, structures or components that failed. This involves inspections, collecting evidence, measurements, developing models, obtaining exemplar products, and performing experiments. Often testing and measurements are conducted in an independent testing laboratory or other reputable and biased laboratory. Failure mode and effects analysis (FMEA) and fault tree analysis methods also examine product or process failure in a structured and systematic way, in the general context of safety engineering. However, all such techniques rely on accurate reporting of failure rates, and precise identification of the failure modes involved. There is some common ground between forensic science and forensic engineering, such as scene of crime and scene of accident analysis, integrity of the evidence and court appearances. Both disciplines make extensive use of optical and scanning electron microscopes, for example. They also share common use of spectroscopy, infrared, ultraviolet, and nuclear magnetic resonance to examine critical evidence. Radiography using X-rays, such as X-ray computed tomography, or neutrons, is also very useful in examining thick products for their internal defects before destructive examination is attempted. Often, however, a simple hand lens may reveal the cause of a particular problem. Trace evidence is sometimes an important factor in reconstructing the sequence of events in an accident. For example, tire burn marks on a road surface can enable vehicle speeds to be estimated, when the brakes were applied and so on. Ladder feet often leave a trace of movement of the ladder during a sleepaway, and may show how the accident occurred. When a product fails for no obvious reason, some energy dispersive X-ray spectroscopy (EX) performed in the microscope can reveal the presence of aggressive chemicals that have left traces on the fracture or adjacent surfaces. Thus an acetyl resin water pipe joint suddenly failed and caused substantial damages to a building in which it was situated. Analysis of the joint showed traces of chlorine, indicating a stress corrosion cracking failure mode. The failed fuel pipe junction mentioned above showed traces of sulfur on the fracture surface from the sulfuric acid, which had initiated the crack. Extracting physical evidence from digital photography is a major technique used in forensic accident reconstruction. Camera matching, photogrammetry, and photorectification techniques are used to create three-dimensional and top-down views from the two-dimensional photos typically taken at an accident scene. Overlooked or undocumented evidence for accident reconstruction can be retrieved and quantified as long as photographs of such evidence are available. By using photographs of the accident scene including the vehicle, lost evidence can be recovered and accurately determined. Forensic materials engineering involves methods applied to specific materials, such as metals, glasses, ceramics, composites and polymers. Most manufacturing models will have a forensic component that monitors early failures to improve quality or efficiencies. Insurance companies use forensic engineers to prove liability or non-liability. Most engineering disasters, structural failures such as bridge and building collapses, are subject to forensic investigation by engineers experienced in forensic methods of investigation. Rail crashes, Aviation accidents, and some automobile accidents are investigated by forensic engineers in particular where component failure is suspected. Furthermore, appliances, consumer products, medical devices, structures, industrial machinery, and even simple hand tools such as hammers or chisels can warrant investigations upon incidents causing injury or property damages. The failure of medical devices is often safety critical to the user, so reporting failures and analyzing them is particularly important. The environment of the body is complex, and implants must both survive this environment and not leach potentially toxic impurities. Problems have been reported with breast implants, heart valves, and catheters, for example. Failures that occur early in the life of a new product are vital information for the manufacturer to improve the product. New product development aims to eliminate defects by testing in the factory before launch, but some may occur during its early life. Testing products to simulate their behavior in the external environment is a difficult skill, and may involve accelerated life testing, for example. The worst kind of defect to occur after launch is a safety-critical defect, a defect that can endanger life or limb. Their discovery usually leads to a product recall or even complete withdrawal of the product from the market. Product defects often follow the bathtub curve, with high initial failures, a lower rate during regular life, followed by another rise due to wear out. National standards, such as those of ASTM and the British Standards Institute, and international standards can help the designer in increasing product integrity.